Hello and welcome back to HW. That stands for homework 2.4. Starting the retrieval. Number 1. Quadrilateral WASP is congruent to quadrilateral BLUE. This is a factoid. This is a fact. Where's the fact? Referencing. This is the fact it's referencing. Mark the corresponding sides and angles on the figures. Ooh, what corresponds with what? Okay, this is the longest side. Clearly. Let's give it a double mark. There's room. Let's give it a triple mark. There's room for it. Where's the longest side here? Okay. This? No, actually this tall guy. And what's next? Okay, this pointy. So the 3 and then the pointy and then we'll give that a 2. Okay, there's 3 and then the pointy. Oh, it's going this way. And actually, here's a clue. They told us that WASP is congruent to BLUE, and they have to name them in the correct order, in the orientation that matches. Now, these have different orientation. Do they? Let's see. Yeah, this one's going counterclockwise, this one's going clockwise. But they're listed in their, each one is listed in the orientation that makes it match the other one. So this one's going clockwise, and they listed the other one in BLUE. So they listed the other one counterclockwise. So we don't actually have to like figure out how long this is and what it matches. We know what it matches next. It's S to P matches U to E. And lastly, the last letter. So they said WASP is congruent to BLUE. The last letter loops around. So P to dub must match E to B. Let's give that a circle. That's a non-standard notation, but I like it. List the 8 congruency statements about line segments and angles. 8. Here we go. Settle in. Segment WA is congruent to segment BL. Segment, I gotta figure out a way to do this faster. AS is congruent to segment LU. And then UE. Oops, this one's kind of reversed. I started with the blue one and then went to the other one. SP, that's okay. Back to the WASP. P dubs segment. Congruent to EB. Wow, that is taking so much brain power. There's 8 of them. Now the angles. Okay, at least we don't have to use the triple name. We can just do angle W congruent to angle B, angle E. Oop, I switched it again. I just started the blue one. It's angle A, angle S, congruent to angle U. No, I screwed up. No, that's right. Angle P, congruent, angle E. Whew. Yes. Require reflection? Yes. They have opposite orientation. One's clockwise, one counterclockwise. We already discussed that. Solve the equation for t. Okay, that means isolate t. That means unwind all the other mathematics around t. So the last step of this expression is this divide by 3. So we're going to undivide it. Times 3. But we have to also blow up the other side by 3 times bigger. Now this side's 3 times bigger. It doesn't look 3 times bigger, but remember it used to be divided by 3. Now it's not getting divided by 3 anymore. Now it equals 18. All this stuff happens, then we add 7, we subtract 7, so let's add that 7 back in, and not subtract that 7, and then that means it'll equal 25. Then a times t times 5, let's not times by 5, and we get, technically we can also divide by the a at the same time. Because 5a is a number. 5 times a is a number, so we can just divide. I'm just going to do it. Too late to go back and do it one by one now. The nice thing about this is these simplified to 1s and we're left with the t that we wanted. What happens over here though? Well, you guys know that when you're multiplying fractions, you multiply across the top, multiply across the bottom. So this is the same as 5 over 5 times 5 over a. Just multiply across the top. It's 5 times 5. Multiply across the bottom, 5a. But now that it's like this is clearly just a 1. And now that we have it written like this, do we even need to write that 1? Because 1 times anything is itself. So this is the thing we want. So t equals 5a. Another thing people do is they just like cross these both out and write 5a. They don't write any of this. But I wanted you to see the logic behind why 25 divided by 5a is the same as 5 divided by an a. Makes sense. Given the figures with congruent angles and side marked on each sketch, first list the parts of the figures that are corresponding and congruent. For example, in problem 1, angle C congruent to angle R. Then determine if a reflection occurred as part of the sequence of transformations that was used to create the image. Okay, we just did this stuff. Just check. From single to double is clockwise. From single to double is counterclockwise. Yes. Don't forget your other stuff. You have to, what do they want? List the parts. Okay, so that means angles and segments. Now here's where, just in terms of segments, AB is congruent to TS and ST because a line has no thickness, so it doesn't matter its orientation. But as part of a bigger thing, let's practice this because the whole triangle does have thickness, and the whole triangle does have an orientation. So if I went from A to B, let's make sure I go from T to S. Okay, and 3 more statements for this one. Don't write this down. Don't write this. That's a reference to this. Oh my gosh, I was off the screen. I am losing my skills. Hopefully it just like bumped or something, I don't know. Should I start this video over? I'm only 7 minutes in. Heck no, I'm not starting over. Use the congruent, so do number 2, remember 8 statements. 8 statements. Use the congruence markings to determine whether the triangles are congruent, similar, or neither. State the triangle congruence criterion connected to the pair of triangles that are congruent or similar. Don't worry about similar. We haven't learned about similar yet. But this is one of the criterion. This is one of the 5. So go back, watch yesterday's lesson. What is it called when we know all, when there's 3 pairs of sides? That's not that pair. Yeah. Double with double. Okay. And triple with triple. What do we call it when we have 3 angles? So let's look at the directions again. State the triangle congruence criterion connect to the pair of triangles. Let me pick a hard one. Let's do number 8. Here we have a pair of angles. So that's an A. We have a pair of angles. What? I'm confusing myself. We have a pair of sides. Sheesh. That's a side. We have a pair of sides. That's a side. We have a pair of angles. So this is SSA. And no, this does not work. Or you can make this complicated sign, not congruent. But many of these are a pattern that will give you congruency. Not all of them, but there are some. Looks like about half. Provide a sequence of transformations that we use to justify. Why are they still doing this to us? Explain how the congruent features indicated on the triangles and the transformations prove the triangles are congruent. Oh. Okay, this is, so in this case, you're talking like, actually, I'm going to take that out. Do not explain. Unless you want to. We got more talking to do about AAS. Remember, they tagged AAS on at the very end. In fact, don't even do number 9. Skip. Describe a sequence of transformations and a triangle congruence criterion to justify that triangle EFD is congruent to triangle. Okay. So the criterions are the 3-letter things. 3-letter nicknames. I mean, the criterions are a logical construction, but we give them 3-letter nicknames. So tell us which one. Yeah, that's fine. Fine, you can do the sequence of transformations. Use the given congruence statements to draw and label 2 triangles so that the corresponding parts are congruent. You can do these with reflection or without. A, B, C, P, Q, R. Okay. Don't forget to give them their markings. I guess that's all that's required. But they want labels so that all the corresponding parts. Okay, fine. Single arc, double arc. What's this corner? Trips. Don't tell me I did that again. Something is my desk is like messed up today. I'm sorry, guys. I don't know if I can recreate the magic. A, B, C, P, Q, R. Triple mark, double mark, double mark, single mark. One arc. Then did I screw this up? No, 2 arc. Trips. Go ahead and give it your best on 12. I've learned my lesson. I'm going to keep an eye on the screen. Keep my eye on the prize. Sorry. We do one. We just did one of these in the retrieval. You guys can handle this. Anything difficult here? Combine like terms first, right? Okay. Oh, here's one. Oh, it's easy. Move this T over there, or not move it, but represent its equality on that side, and then don't add this W, take it away, but then take away W from that side. You're done. Equilateral triangle. You guys are good at that. And a rhombus. Rhombus using this as the side. So since all 4 sides of a rhombus are the same, they all need to be this size. Well, grab a compass and set it to that size and mark it out. Then they also want you to use this angle. Great. You needed a ray to start using anyway. Swing your compass up, mark it. Swing your compass out, mark it. You got it. Done. Sorry for being off the screen, guys. I will, if you get this far, the second secret word is water bottle. I wasn't going to do a second secret word, but for being off the screen too much. So on the board, it'll say prize claimed, and then second also. So if you look up right now and it says prize claimed second also on the board on the 24th of October, then sorry, no dum-dum for you. But if there's not second also, then you can come get a dum-dum. All right, see you later, bye.